everybody. My name is David Lane. I am the chairman of Consequential Robotics, and it's my great pleasure today to be with two of my favorite people, colleagues and friends, Sebastian Conran and Tony Prescott from Consequential Robotics. And we're going to be talking about creative coding with socially engaging robots, and in particular the MiRo-E. So first of all, let me introduce my colleagues and friends. Sebastian Conran, one of the UK's most talented, award-winning international designers. He's the chief designer of MiRo, and indeed is the CEO of Consequential Robotics. So good. Hello, Sebastian.
Hi there.
Where does this find you today?
Well, I'm in sunny West London, and we've got roadworks going on outside. So if you hear the sound of pile drivers, you'll know it's not my tummy rumbling.
Great. And then also with me, again, my colleague and friend, Professor Tony Prescott, who is the chief scientist at Consequential Robotics, but also Professor of Cognitive Robotics at the University of Sheffield. So, Tony, hello. Where does this find you today?
Good morning, David. Yeah, so officially I'm on holiday. I was in Scotland near to you last week, but I'm now back in Sheffield and at my desk for this.
Brilliant. Okay, and I'm in Edinburgh in Scotland, so the three of us are all in completely different places in the UK, but together virtually, if not physically. So more and more people are wanting to learn about coding. Kids in schools, students in universities, people in companies, people at home. And there are lots of reasons to want to do that, sometimes because you have to, because it's your job, or you want the job, or just out of interest. And we think that with the MiRo-E socially engaging robot, we've got a great platform that people can use, of all kinds, people can use to learn to program. So we thought first we'd have a think about and look at what is it about MiRo that makes it socially engaging. So Tony, you've been intimately involved in the development of MiRo's behavior in particular. What is it? What are the features of MiRo that make it socially engaging?
So, David, my background is psychology, and I spent most of my career thinking about what makes human and animal behavior engaging and interesting. And we've tried to program that into the robot. So I want to show you a short video of the robot. Can you see that?
Yeah, it's looking good.
So this is an earlier prototype of MiRo. And actually the robot is at the Swiss Embassy in Washington. I was there for an event. And you're going to see MiRo doing some of its behavior. The behavior is generated by its program, and it's fully autonomous. So the robot is controlling all its own movements. There's nobody remote controlling the robot. So if I set it running, what you'll see is MiRo moving around, turning its head. You can see lights in its body that reflect its activity. And it's using its sensors, its cameras, which are its eyes, and its ears, which have microphones, to detect sounds, movement, and faces. And this gentleman is one of the members of staff at the Washington Embassy. He's never met a social robot before, but he's immediately intrigued by it and behaves towards it as you might towards a social animal like a dog or a cat. And you can see that MiRo is interested in meeting this person, moves towards it, engages with it through attention, looks at this gentleman, and responds particularly to touch. So when he touches the robot on the head or the body, the touch sensors are picked up by the program, and MiRo's lights go green to show that, if you like, he's happy. So this behavior that we can program into the robot makes it a social entity. It's clearly a robot, but it's also clearly has some social capability that we've only ever seen before in people and animals.
Fabulous. So that looks like a lot of fun. I can imagine that if I was learning to program and I was able to put behaviors onto a robot like that, I'd quite enjoy doing it. It would be good fun. So we'll look forward to learning more about that shortly. So Sebastian, you've been instrumental in the physical design of MiRo and its embodiment, as we call it. Is it a dog or a rabbit?
Well, that's a really good question, David. I brought Dave, my home MiRo, with me to Dave, and it's both a dog and a rabbit, because when we started designing a robot platform with Tony, we thought, oh, people are worried about robots. People have seen robots on movies; they're dystopian. So what we want to do is design a friendly robot that people will want to be with. Now, designing a human being is a very, very complex robot. I mean, really complex. But what we can do is we can replicate the sort of activity and the behavior that you get in a small domestic animal. So we firstly looked at having a dog, because a dog is man's oldest friend. I mean, human beings have been living with dogs and working with dogs for over 11 millennia, 11,000 years, in fact. So dogs and human beings are an obvious choice, but dogs are usually predators, and they've got their eyes close together so they can see prey in stereo vision and leap onto it. Whereas another cute animal is a rabbit, and rabbits are what we call prey, and they have their eyes on the side of their head so they can look behind them and see if a dog is coming up to nab them. So what we've done with Miro is that we've got the eyes sort of slightly far apart, although the cameras are pointing forward, and it's got ears which swivel, and it's got a tail which wags, and it's got eyes which blink like a real animal. So what you've got is something that people want to work with, even before they know what it does. They like it, and that's the most important thing, is get someone to, the first 15 seconds to get someone to actually want to work with something.
That's really good. So I can see that for when people are learning to program, it's going to be great to have a robot that has those features and the behaviors that Tony said. So we've been working quite hard on developing the programming interface for Miro, and we now have a version of Miro that works not only on the robot, but using supercomputers in the cloud. And maybe Seb, you can say a little bit about how we've done that and the way that that makes Miro suitable for people for use in classrooms, and indeed for people who are programming in the remote environments that we find ourselves teaching and learning in post-pandemic.
Well, the thing is, when you talk to a lot of young pupils, especially creative mindset pupils, you find that coding sounds a bit dull, AI coding. Today we're going to do AI coding because it seems fairly abstract. So what we've got is a tangible physical demonstration of their coding. So it's not like they're just seeing it on screen. They're actually being able to teach a little dog to do tricks, which is basically what you're doing with coding, is you're teaching a machine to have behaviors.
Great. So Miro's got lots of sensors on it, it's got lots of actuators, it's got lots of degrees of freedom, lots of different ways that it can move around. We've developed a programming interface that works in the cloud, that means that people can program Miro from their browser on their computer and practice using it even though they don't have the robot with them, and then later on download it to the robot, which means if you're doing remote learning, imagine that you're working from home rather than in a classroom, then there's lots of ways, even if you don't have a Miro with you, you can still learn to program and practice. So maybe Tony, you could say a little bit about what are the features of MiRoCLOUD, as we call it, that make it intuitive and easy to use for this kind of responsive blended learning.
Sure. So what I'll do is I'll share my Firefox window with you. Can you see that there?
Yeah, it's looking good.
So this is the landing screen when you log in to MiRoCLOUD. This is what you see. So normally what you would do is you would click open here, and that would load MiRoCLOUD, and that takes a minute or two. It's quicker actually if there's other users. And once that's loaded, you click launch. And when you do that, you get this window up, which is a window where you can see your simulated robot. That's our simulated Miro sitting in the middle. Can you see my cursor?
Yeah, it's looking good.
Yeah, so there he is, sitting on a table environment with a cube and some cans and so on. You can see what Miro sees. So these two views down here show you what Miro is looking at with his simulated eyes. He's looking at the tabletop, and you can see out of this eye, he can see the cans in the corner. So as Seb was saying, the eyes point out quite a way, so he has quite a wide angle of view. We can make a sound, so we can make a clap sound. Did you hear that? I'll do that again. And you can see that he picks that up with his microphone. We can simulate patting. So if I click this, you'll see these sensors in his head light up. So we've stroked him on the head there, and we can stroke him on the body. You see those sensors lighting up. So there's various ways of interacting with the simulated robot, as you might with the real robot. And then, of course, we can program in. So this is the window on the left here where we can write our programs. We can do those in a visual programming language called Blockly. So we always have a block called program start. And then we can get Miro to do stuff. So let's say we want to move him forward. So we'll do move forwards 2 steps. And then we might want to turn. So let's say we'll turn Miro 90 degrees. It'll turn left for 90 degrees. And then let's move Miro forward again. And let's go forward for 6 steps. So I've written a simple program. I can now run it in Miro and see what happens. So I click play here, and hopefully we'll see some action. So there's Miro setting off. He's moving forward. Now he's turning left. And now he's going to go forward for 6 steps. I was hoping he's going to run into those cans. He's going to miss them. That's because the simulation, like the real environment, has some noise in it. So he didn't precisely turn 90 degrees. Let me reset my simulated world. Whoops.
It's so intuitive and so easy to work. I mean, we've had sort of primary school kids actually writing quite sophisticated programs on it, haven't we?
Yeah. Primary school kids are generally much better at this than I am. So let me say move forward 1 this time and see where that goes. So we've moved him back to his starting position. So forward 1 step, turn 90 degrees. This is looking more promising. And here you see the benefit of a full physics simulation. So when Miro bumps into this pile of cans, they actually fall over as you might expect them to in the real world. And there are lots of simulated robots that have been used as teaching tools, but they don't have full physics. So the robot doesn't behave in simulation like it would in the real world.
So that's the benefit of having the supercomputer, isn't it?
So and absolutely, you need a lot of processing power to make this work. See, Miro is pushing this can, and I think they're both going to fall off the table. There they go. And you can see Miro now is on the floor looking at the table legs. The other benefit of simulation is that robot can fall off the table without breaking. So don't try this with your actual Miro. But the good thing is that having written this program, and if I had a suitable block of cans, I can put the IP address of a robot into this cell down here. Can you see that? If I type in an IP address, so it could be Seb's robot Dave. I could put in Dave's IP address. Then I just click play, and rather than playing in simulation, it plays on the physical robot. So this could be a robot that is in the classroom, and kids could take turns to program that robot. Or it could be a robot that's at home, or in Sheffield Robotics, or in Edinburgh Robotics, and people could be remotely controlling a robot that was in the university.
So what you're saying, Tony, is that even with a humble home computer, you know, a 5-year-old laptop or something, you've got access to a supercomputer in the cloud.
Yeah, and it's pretty much instant. You don't need a great computer. You can do it with even a tablet, and it will run close to real time, as you saw, on the supercomputer in the cloud. So it doesn't matter if yours is quite an old computer or an old tablet, it will run at the same speed. as anyone else's. So it's great in terms of accessibility. No need to install anything. It runs on any operating system.
Right. So I can see that's going to be really useful for teaching and learning situations where, you know, people are working from home and not working in a classroom. Maybe different pupils or different students take the robot home each week and disinfect it, and everybody runs their code on somebody's real robot, and you dial in through a Zoom call or something like this in order to do it. So that sounds really, really powerful and really appropriate for the way we're doing teaching and learning now. And I can easily see we were having fun there, just trying to knock over the cans. And actually, it's creative. There's no limit to what you can think about doing. It's down to the creativity of the individual to try and think of things to do with Miro. So I think, and teachers as well as students. So
you're not limited to that tabletop environment. We've got several different environments which are already programmed in. But because this is using a full physics simulator, you could also design your own environment and put Miro into that. So you could make a simulated environment that's similar to your classroom.
Yeah.
And so that you can actually match the simulation to the real world rather than vice versa.
Hey, Tony, you were saying that you could move it from the Blockly interface, which you'd start off with, to sort of professional level Python. Can you show us how that works?
Yeah, so let me share my screen again. So so that's the code that we just wrote there. And if I just click on this button here, then that's what that looks like in Python. You can see that each of those blocks is converted into a function call with a parameter. And if you're new to coding, then this might be slightly intimidating, so you can write in Blockly. But once you get better at coding, and so more advanced students that are doing GCSE or A-level or university might want to program directly in Python, because skilled programmers find that faster than dragging and dropping boxes. So you can you can switch back between the two. So as soon as you add another block, it converts it into Python, and you can edit it there as Python.
Brilliant.
I think I'm going to stick with Blockly for the time being.
But that's really good, Tony. And for that reason, you know, Miro is not only being used for teaching programming, obviously, it's being used by researchers. They're using it a lot for doing basic research in cognitive psychology and social robots, and how we can use them in all sorts of applications in healthcare for cognitive support and many other things that we don't have time to talk about on this video log today, but we will do some other ones, I think, where we can explore that a little bit more. So listen, time's getting on and time's up. I think we could go on forever. We need to draw this to a close, I think. It's been great talking to you both, Tony and Sebastian. Wonderful. I think what you've created in Miro is absolutely wonderful. Hello, Miro.
Dave.
Also called Dave. Yeah, very confusing. If you want to learn more about Miro, then do go to our website, which is miro-e.com. Say that again, Miro, MiRo-E.com. You can find out all about the robot there. You can connect with some of our learning partners, who are the people that are using Miro and taking Miro into schools. And you can join competitions, and you can even try out MiRoCLOUD. So you can try and do some of this for yourself if you want. And if you'd like to see more examples of Miro in action doing different things, then if you go to YouTube and search for the Consequential Robotics YouTube site, then you'll see lots of videos there of different things Miro has been doing. And indeed, you can go to Professor Tony Prescott's YouTube site as well, and you'll see even more examples there with all his followers following it. So Sebastian and Tony, thank you very much for that. It's been wonderful. I'm hugely enthusiastic. I can't wait to get my hands on a Miro and start programming it and doing fun stuff with my family to start with. And it's been great speaking to you today. Thank you.
Have a lovely weekend. Bye-bye.
Bye-bye.